Your objective for lesson 9 is I will analyze data to problem solve. So we're going to be looking at bar graphs and picture graphs and line plots, all the things that we've looked at in this module, and we're going to be answering questions about those. And you're also going to be making some more graphs of your own. So this is a pretty big lesson, and it's a pretty big problem set that goes with this lesson as well. So this graph that you see on the screen shows how a group of friends spent their money at the fair. So this is going to show how much money they spent on games, how much money they spent on food and parking and rides. We know that when we're looking at bar graphs, we need to pay close attention to what the scale is and what the scale represents. We know that in between 0 and 10 would be $5, and we know that in between 10 and 20 would be 15, so it's going to be important to know what is halfway between the amounts that are on your scale, because we can see that food is halfway between $20 and $30, parking is halfway between $0 and $10, and rides is halfway between $30 and $40. So you're going to have to know what those bars go up to and what amount that is. So the question that we're going to be working on for this first problem that you're going to answer on your piece of paper in your binder is how much more money did they spend on rides than they spent on parking. So I want you to take a look at this bar for rides and this bar for parking. You see that the rides goes halfway between 30 and 40, and we know that the number that comes halfway between 30 and 40 is 35. So that tells me that they spent $35 on rides. And then this parking one is $5 because we know that halfway between 0 and $10 is $5. So now that we know the amounts and we know what the question is asking, how much more did they spend, you should be thinking of subtraction. And this is something that you should be able to do in your head based on what the numbers are. So for this first one, I want you to write the answer to this question. How much more money did they spend on rides than parking? Answer that on your piece of paper and push play when you're ready to check it. Okay, so you should have put that they spent $30 more because when you take 35 minus 5, you're left with $30. So that first question was pretty simple. Why do you think more money was spent on rides than on parking? Well, usually only pay for parking once, and whenever you go in to a fair or a carnival, then you're probably going to spend more money on rides because you may ride rides more than once. So the next question says the friends take a total of $120 to the fair. How much do they have left after the fair? So we have to figure out something first before we can even do any type of addition or subtraction problem. We know that they took 120, but we're trying to figure out how much money they have left when they leave the fair, but we don't know how much they spent at the fair just yet. But the bar graph is actually going to help us figure that out. So the first thing that we need to do is figure out the total amount that they spent at the fair. So on the bar graph, we can see that for games, they spent $30. So I want you to write $30 on your piece of paper. For food, they spent 25 because we're halfway between 20 and 30. We know that for parking, they spent $5. And we know that for rides, they spent $35. So to figure out how much money they spent in all at the fair, we're going to have to add those four amounts together. So I want you to do that on your paper so we can figure out how much money they spent total, and then we can figure out how much money they have left at whenever they leave the fair. So push pause, figure that out, and push play when you're ready to check it. So when you add all of those amounts up for the games, food, parking, and rides, you should have got a total of $95. So we know now that whenever they were at the fair, they spent $95. So looking back at the question, it says that they took $120, and we know that they spent $95. So now we have to figure out the difference between $120 and $95 to see how much money they have left after they leave the fair. So I want you to work out that problem now on your piece of paper to see how much money they have left after the fair, and push play to check your answer when you're done. So when you take $120 and you subtract $95 from that, you should have gotten $25. So that answered the question for how much money or how much money do they have left after the fair. Okay, looking at the same chart, we've got two different questions that we're going to look at now. This first one over here says, how much less did the friends spend on rides than on games and food combined? So here's this word right here, combined. This should be telling you right now that this is going to be a two-step problem because you're going to have to combine games and food before you subtract that from the rides. So your first step needs to be combining how much they spent on games and food. So go ahead and do that on your piece of paper. So whenever we know that they spent $30 on games and $25 on food, so when you combine 30 and 25, we get that they spent $55 on games and food combined. So it says how much less did they spend on rides. So on the rides, we know that they spent $35. So now all we have to do is subtract $55 and $35 to figure out how much less they spent on the ride. So I want you to go ahead and do that on your paper to see what the answer for this question is and push play when you're ready to check it. So when you take 55 minus 35, you're left with $20. So that tells me how much less they spent on rides than they did on the games and food together. Next question says, parking cost $1 for each hour. The group of friends arrived at the fair at 3 p.m. What time did they leave? So if we know that they spent $5 on parking and an hour cost $1, then that must mean that they were there for 5 hours. So if they got there at 3 p.m. and were there for 5 hours, then on your piece of paper, I want you to write what time did they leave. So they would have left at 8 p.m. because when you add 5 hours to 3 hours, that gives you 8 p.m. Okay, so now we're looking at a line plot and not the bar graph anymore. So we need to know what this line plot is showing, and it says that this line plot shows the links of the crawfish in Mr. Nice third grade science class. We can see that all of the links are going to be in inches, and we know that each X stands for one crawfish based on what this is saying. So it says, what is the total length of all of the crawfish that are 3 inches long? So in order to solve this problem, we're going to have to go and we're going to have to find the 3 inches. If we know that each X represents one crawfish and each one of these crawfish on this part of the line plot are 3 inches long, then it's like you're saying, like there's 1, 2, 3, 4, 5, 6. So that would stand for 6 crawfish. So it's like it's saying that you're going to take those 6 crawfish and you're going to line them up side by side. So what is going to be the total length of all 6 of those crawfish? So if I have 3, 3, 3, 3, 3, and 3, that's the same thing as saying I have 6 times 3. So now that you know how to work this problem and you understand it a little bit better, I want you to put what is the total length of all of these crawfish that are 3 inches long. So write that on your piece of paper and then push play when you're ready to check it. So the correct answer is that they are 18 inches long if I were to put them all in a row side by side. Okay, it says Miss Curry's class also measures the length of their crawfish. They noticed the number of crawfish that are less than 3 inches long is half of the number in Mr. Nye's class. How many crawfish are less than 3 inches long in Miss Curry's class? So this one's a pretty long problem, so you may have to back up and reread using your reading strategy to understand this question a little bit better and exactly what you need to do to solve it. So I'm going to push pause and I'm going to reread the question, and I want you to do the same thing so you know how you're going to solve this question. So when you think you know what to do for this question, I want you to push play. So hopefully you can understand this just a little bit better. But Miss Curry's class, what they're saying is that they noticed that the number of crawfish that are less than 3 inches long is half of the number that Mr. Nye's class has. So whatever Mr. Nye's class has, however many that are less than 3 inches, they have half of that number in their class. So what we need to be looking at are these inches on the line plot. And we need to figure out how many crawfish are less than 3 inches. So if I've got 4 right here and 3 right here, I know that that's 7. And then I've got 3 right here, and I know that 7 and 3 together equals 10. So Mr. Curry's class has 10 crawfish that are less than 3 inches, and our Mr. Nye's class, and then Miss Curry's class has half of that in their class that are less than 3 inches. So all we need to do to figure this out is what is half of 10, and that's going to tell us how many are in Miss Curry's class that are less than 3 inches. So I want you to write that number down on your piece of paper and push play when you're ready to check it. Okay, so you should have got that there were 5 crawfish in Miss Curry's class, and this is a way that you could have thought of it, 10 divided by 2, because when you take 10 divided by 2, you're taking 10 and you're just cutting it in half, and we know that 5 and 5 make 10. So we know that 5 is half of 10, and that's how many crawfish she has in her class. Okay, so this next question says, use the line plot in the chart below to find the total number of crawfish that all of the 3rd grade classes are studying. So, Miss Curry, we talked about earlier, she has 23 crawfish, Mr. Franklin has 21, and Miss Noble has 24. We don't know how many total are in Mr. Nye's class, so we're going to look over here at the line plot on the screen. We're going to count all of those X's to fill that in on this chart. And once we know Mr. Nye's amount of crawfish, then all we will need to do is add all of these together to figure out how many crawfish are total in the 3rd grade. So I want you to work on this problem on your piece of paper, and whenever you're ready to check both answers, that what goes here and then how many are total in the 3rd grade, I want you to push play. So when you counted all of the X's on the line plot, you should have got 21 crawfish for Mr. Nye's class. So whenever you take 21 plus 23 plus 21 plus 24, you get a total of 89 crawfish that the 3rd grade classes are studying. The next question says, the crawfish are kept in 3 small tanks, and there are 3 crawfish in each tank. How many tanks does Mr. Nye's class need? So we just figured out that Mr. Nye's class has 21 crawfish, and the crawfish are in small tanks, and there's 3 crawfish in each tank. So this is really going to take us back all the way to Module 1 whenever we were working with multiplication and division, and when we were working on tape diagrams, and you've got to ask yourself, is this problem telling me how many are in each group or how many groups there are? Because you have to figure out how you're going to answer it, and are you going to be multiplying or are you going to be dividing to answer this question? So I want you to look at this and write the answer to this question on your piece of paper, and whenever you're ready to check it, you may push play. Okay, so the way that we would have solved this was saying 21 divided by 3, because we knew the total amount of crawfish was 21, and we knew how many were in each group. What we didn't know was how many groups we had. But when you take 21 divided by 3, that tells us that there were 7 tanks that Mr. Nye had in his class, and those 7 tanks represent how many groups there were. So we're going to be ready for the problem set. If you will get that out and have that ready. Okay, so this first part of the question, we've got to do some work to complete the chart before we go and work on part A and part B. So number 1 says 4 children went apple picking. The chart shows the number of apples children picked. So we see that Stuart picked 16. Roxanne, we don't know how many she picked. Trisha picked 12, and Philip picked 20. Altogether, when you add all 4 of these, you get 72, but we have to figure out what Roxanne is. So the way that you're going to figure out what Roxanne is add together Stuart, Trisha, and Philip, and when you add those 3 together, all you have to do is take that away from 72, and the amount that you have left is going to be what Roxanne picked. So over here to the side, I want you to write 16 plus 12 plus 20, and I want you to figure out how many that is total, and we're going to subtract that from 72, and what is left is going to leave us with what Roxanne picked whenever she went apple picking. So I want you to push pause to get that figured out and push play when you're ready to check it. So when you add 16 plus 12 plus 20, you got 48, or you should have got 48. And then when you take 72 minus 48, you're left with 24. So that leaves you with what Roxanne should have picked when she went apple picking. So now we just answered part A where it said find the number of apples Roxanne picked to complete the chart. So we're good for part A. Now we're going to take the information from this chart and we're going to make a picture graph. So it's like what we looked at in the very first lesson of this module where you've got pictures as the symbols and the pictures represent so much of what you're working with. So that's what this key is right here for. So we're going to have to pick what picture we want to use in our picture graph. And I'm thinking that since we're using apples, then it probably is a good idea just to use an apple as our symbol. And we have to figure out how much is one apple going to represent. And this is the part, it's kind of like what we do in bar graphs. We have to figure out what our scale is going to be on our bar graphs. So when you're trying to figure out how much you want each apple to represent, you've got to look up here at the chart. I can't say that each apple represents one apple because then I'm going to get over here to Roxanne, and whenever I get over here to my chart and I'm going to see Roxanne's name, I'm going to have to put 24 apples down. And yeah, you can do that, but whenever you're making a picture graph, it's not good to have that many pictures for one person or whatever it is that you're working with. So you want to pick a symbol, and you want that symbol to stand for a certain amount, so that way whoever's looking at your graph can read it easier, because if you have 24 apples, it's not going to be as easy to read. It's going to be a lot taller, and it's going to take you a lot more time. So the way that we figured this out is by looking at 16, 24, 12, and 20. And the first thing that we need to do is we need to ask ourselves, what numbers could we skip count by and say 16, 24, 12, and 20? Because that's going to help us figure out how many each apple is going to stand for. So over here to the side on top of this, I want you to write down the numbers, which are the factors. What factors will we put down where we could skip count by that number and say 16, 24, 12, and 20, and then we're going to go from there to see how much each apple is going to represent. So push pause and get those numbers written on your paper, as many as you can or that you can think of, and then push play whenever you're ready to check it. So I know that I can skip count by twos and say 16, 24, 12, and 20. I can't skip count by threes because if I were going to skip count by threes, I would not say 16 and 20. I can skip count by fours and say 16, 24, 12, and 20. I can't skip count by fives because I wouldn't say 24, I wouldn't say 16, and I wouldn't say 12. I can't skip count by sixes because I wouldn't say 20 and 16. So if I keep going up more to like 7 and 8 and 9, 10, then it's going to get a lot harder to say these numbers. So now we've come up with two numbers that we could use for what each apple is going to represent, but we have to think what would be best to use. So if I'm skip counting by twos, how many times would I have to skip count by twos to get me to 24? And I know that 2 times 12 is 24, so that means I'd have to draw 12 apples. So whenever I'm thinking about skip counting by fours, I know that I can skip count by fours 6 times and get 24 because I know that 4 times 6 is 24. So that makes it a little bit easier because I would only have to draw 6 apples instead of 12. So I think that the best bet for us is to go with saying that each apple could represent 4 apples. And then we would know how many to draw for each person when we get down here to part B when we have to create it. So now we're going to move on to part B and start creating our graph. So we need to label our picture graph. Down here it says child, so there's 4 different spots because there's 4 different kids. So we need to put Stuart, Roxanne, Trisha, and Philip down here at the bottom. So go ahead and do that now on your problem set. And since this isn't a bar graph, we don't really need a scale right here where we were skip counting by fours, because when we draw our apples, whoever's looking at our picture graph, they know that they're going to see that each apple represents 4 apples. So whenever they're looking at our picture graph, all they have to do is skip count by fours for every apple that they see. So for Stuart, let's start with Stuart. He had 16 apples. I know that whenever I'm skip counting by fours, I go 4, 8, 12, 16. So that tells me that I'm going to have 4 different apples that I'm going to draw for Stuart. So I want you to do that now on your paper. Draw 4 different apples. So that's representing 16 apples that Stuart picked. And then we're going to keep doing this for Trisha, Roxanne, and Philip. I see that Roxanne, or Trisha is my next person. Trisha had 12 apples picked, and I know when I skip count by fours, I go 4, 8, 12. So that's 3 different times that I'm going to draw the apples, because 3 groups of 4 would give me 12. So what I'm going to let you do is I'm going to let you go ahead and finish for Roxanne and Philip, drawing how many apples there need to be above their names to show how many apples they picked. And whenever you're finished with that, you can push play to check your answer. Okay, so this is what your picture graph should look like. Stuart has 4 apples, Trisha has 3, Roxanne has 6, because I know that 4 times 6 gives me 24, and Roxanne picked 24 apples. Philip has 5 apples above his name, because I know that 5 times 4 gives me 20, and Philip picked 20. Okay, so we already had Stuart and Trisha done together. So for Roxanne, you should have had 6 apples, because I know that 6 times 4 gives me 24, and Roxanne picked 24 apples. Philip has 5 apples above his name, because 5 times 4 gives me 20, and Philip picked 20 apples. I really wanted you to pay close attention to how we did this picture graph, because I know that you're going to see this on your end of module assessment. I think the hardest part of a picture graph is actually picking out what this key is going to represent. Making a picture like we did for the apples, that's pretty easy, but you really have to think to be able to tell me what each picture is going to represent. That's why I showed you how to look at the numbers in the chart and really think about what numbers you could skip count by and say those numbers, because that's going to be the easiest way for you to do your key whenever you're making a picture graph. So really wanted you to understand how we made a picture graph, because I know that you're going to see this on your assessment whenever we're finished with this module. Okay, number 2 says use the chart or graph to answer the following questions. So we're going to be flipping back and forth from this page to the front page so we can answer the questions based on the picture graph or on the chart. So part A says, how many more apples did Seth and Stuart, or did Stuart and Roxanne pick than Philip and Trisha? So we're going to have to go back and see how many Stuart and Roxanne had together, and see how many Philip and Trisha had together. And since it's asking how many more, you should be thinking of subtraction once we've figured out the total for Stuart and Roxanne and Philip and Trisha. So the first thing that I want you to do is go and add together Stuart and Roxanne and add together Philip and Trisha, so we know how many those are combined, and then we'll go on to our subtraction problem. So Stuart and Roxanne had 40 apples altogether, because we had to do 24 plus 16, and Philip and Trisha had 32 apples altogether, because we needed to add 20 plus 12. So now we need to figure out how many more Stuart and Roxanne had than Philip and Trisha had. So we're just going to take the 2 numbers that we found, 40 and 32, and subtract those. And then I want you to answer the question that it's asking you in a complete sentence over here on this side of your paper. So go ahead and find the answer to the question by writing down your subtraction problem and then answering it in a complete sentence. And once you have that done, I want you to push play. So when you subtract 40 and 32, you're left with 8. So to answer the question, you should have put Stuart and Roxanne picked 8 more apples than Philip and Trisha did. So now we're going to move on to part B. It says Trisha and Stuart combine their apples to make apple pies. And we did not add together Stuart and Trisha up here, so we're going to have to get a new number You can't look up here and look at 40 or 32. We're going to have to add Stuart and Trisha together this time. Um, it says each pie takes 7 apples, so how many pies can they make? So the first thing that we have to figure out is how many apples do Stuart and Trisha have all together. So I want you to look back at your chart and add their two amounts together so we know how many apples we're working with this problem. So get that problem written on your paper for part B and push play when you're ready to check it. Okay, so you should have added 16 plus 12, and that tells us that Trisha and Stuart have 28 apples altogether. So now we're coming to the second part of our problem because this is more than one step. It says each pie takes 7 apples. How many pies can they make? So you should be thinking of division right now because this right here is the total. We have the total amount of apples. We know that there's 28 apples, and we know that each pie takes 7 apples. So what that's telling me is I've got a group here, or a pie, that's going to take 7 apples, so I have to figure out how many more pies can I make if I have 28 apples altogether. So you're thinking of division. I'm going to want to see a picture that goes with this. It's been a while since we worked on a lot of multiplication and division. We did a lot of drawing groups and arrays back in Module 1 and Module 3. So for this one, since we're working on a division problem, I actually do want to see the groups here and how many groups you're going to make. And that's going to tell you how many pies that there will be. And I also want you to write the division sentence that you're going to use to help you solve this. And once you've come up with your answer, you can write that answer in a complete sentence over here on this side of your paper. So push play whenever you have all of that finished and you're ready to check it. So when you were drawing your groups, you should have had 4 groups of 7 because I know that 7 and 7 and 7 and 7 makes 28. And the division sentence that went with it is 28 divided by 7 because that's the numbers that we were working with in the problem is equal to 4. So that tells me that my answer was Stuart and Trisha can make 4 pies. Okay, moving on to question 3. Question 3 says, Miss Pacho's science class measured the lengths of blades of grass from their school field to the nearest 4th inch. The lengths are shown below. So this is telling me that we're probably going to be working with some type of line plot because this is what we've always started with when we've made our line plots. And you can see that they measured them to the nearest 4th inch. And just a reminder, I see a 1/2 inch right here with a 2. I see 2.5 again right here. But I don't see any other halves other than that. So this is just a reminder that 2.5 also is the same thing as 2 2/4 because you're going to see the 2.5 on your number line, or you can write it with 2 2/4. But I do want you to remember what a 1/2 and a 2/4 mean the same thing. So we're probably going to have to be flipping back and forth a lot for this one too, so we know how to make a line plot. This for part A says make a line plot of the grass data and explain your choice of scale. I'm going to cross out the explain your choice of scale because we all know that we're going to be labeling it with fourths because that's all that we see over here on the actual chart. So this right here doesn't give you a line, but you know with a line plot you got to start with your smallest number and the last number on your line plot is going to be the largest number. And since these are all fourths, you know you're going to have 1/4 and 2/4 and 3/4, and then you're going to have to keep putting that in between each whole number. So first thing that you need to do is find the smallest number because that's where you're going to be starting on your line plot. And whenever I'm looking through all of these numbers, I see that the smallest number is actually going to be 2. So we're going to start our line plot at 2, and then we'll go 2 1/4, 2 2/4, 2 3/4, and then our whole number after that would be 3. And then we're going to keep going. And as I'm looking around here, I don't see any other whole number but 2 and 3. So that tells me that I can probably stop at 3 3/4 because the next number that I would plot after 3 3/4 would be 4. And I don't see that whole number 4 anywhere on the chart. So that means that we're going to be going from 2 to 3 3/4 on our line plot. We know based on what this says right here what the title is going to be. We know we're going to have to label our numbers for inches, and we know that each X, based on what it says up here, Each X is going to represent one piece of grass because these are all of the different pieces of grass that they measured. So we're going to have to go over here and we're going to have to draw our line. Mine's very not straight. I'm going to have to fix that. Once again, remember that we're starting at 2, and then we're going to have to go to 2 1/4, 2 2/4, which we know is the same thing as 2 1/2. Then we're going to have to go to 2 3/4. And we know that the next one, if I kept listing fractions, it would say 2 4/4, but we know that 4/4 is the same as 1 whole, so I'm actually going to be going to 3. Then I've got 3 1/4, 3 2/4, and then I've got 3 3/4, and if you remember when we just looked on the chart, that was the highest one that we saw on the chart, so I'm going to erase some of my line because I'm actually going to stop right there at 3 3/4. Going back to the chart, the title is lengths of blades of grass, so we're going to need to put that on our paper for our title, so length of blades of grass, if I can spell correctly. And then we're going to have to label that the numbers are inches, and we're going to have to label that each X that we're going to be putting on our line plot is equal to a blade of grass, or a piece of grass, and a blade of grass is the same thing. Remember, if I'm going too fast for you on this part, you're going to have to push pause and stop it so that way you can catch up with me and you've got everything labeled like you need to. So now that we've got our numbers on our line plot and we have everything labeled, I'm going to let you go ahead and start putting all of the X's on your line plot. Make sure that you're going back and forth and that you're checking off the numbers on the chart as you're putting them on the line plot, so you're not putting it more than once or twice on the line plot. So I want you to go ahead and plot all of your X's on the line plot, and whenever you're ready to check that, you may push play. Okay, so yours should look very similar to mine. You've got 1 X above 2 inches, 3 X's above 2 1/4 inches, 2 X's above 2 1/2, or 2 2/4. You've got 6 X's above 2 3/4, 4 X's above 3 inches, 5 X's above 3 1/4 inches. There's no X's above 3 1/2 or 3 2/4, and there are 3 X's above 3 3/4 inches. So now we're ready to move on to the questions about this line plot. It says how many blades of grass were measured and explain how you know. We did that question a lot when we were working with line plots. The way that we figure out how many pieces were measured in all is by counting all of the X's. And then we know that whenever we're explaining how we know, it's because that's how many X's were on the line plot. So I want you to go ahead and answer part B and push play whenever you're ready to check that. Okay, so there were 24 blades of grass measured because there are 24 X's on the line plot and each X represents one blade of grass. So you should have counted all of the X's and you should have come up with 24 to be able to answer question B. Question C is asking what was the length measured most frequently on the line plot? How many blades of grass had this length? So we're looking for the length that has the most X's above it. And that tells me right now that it's 2 3/4. Since it has 6 X's above it, that tells me that there were 6 blades of grass that had this length. So to answer this in a complete sentence, we will say the length measured most frequently was 2 3/4, and there were 6 blades of grass this long. Part D says how many more blades of grass measured 2 3/4 inches than both 3 3/4 inches and 2 inches combined. So here's that word combined, so you are automatically thinking you're going to have to combine two things together before you do your other subtraction problem that goes with this one. So you need to look up at the line plot, and we're going to combine 3 3/4 and 2 inches. So here's 3 3/4 and here's 2 inches. I see one blade of grass is 2 inches long and I see 3 blades of grass is 4 inches long. So That tells me that 3 3/4 and 2 inches is going to have 4 blades of grass. And now we're going to compare that to 2 3/4. 2 3/4 had 6. So all we need to do down here is actually write our problem. 6 minus 4 is going to be equal to 2. So to answer the question, there were 2 more blades of grass that measured 2 3/4. Let me move this up some. Than 3 3/4 and 2 inches combined. So double check your answers with mine, change anything, or if you need to push pause and get some of this written down, go ahead and do that. This was a really long video for lesson 9, but it had a lot of stuff in it, and you're going to see a lot of this stuff on your end of module assessment for this module because it's working with a lot of graphs and answering a lot of questions based on the graphs. So my main goal for you whenever we get to the end of module assessment is that you really read very closely the questions and really answer what they're asking you. And whenever you have to create a picture graph or a line plot or a bar graph, that you remember to label it and you remember how to do it correctly, because there's a lot of stuff in this module. I know it was a really short module, but there was a lot of things in this module that are really important for you to know. So you're going to be ready to move on to the exit ticket. So whenever you have completed the exit ticket, you may bring that to me.